Alright, welcome back. So this part is going to cover domain and range from a graph. Since functions are relations, right? Anything that applies to a relation would also apply to a function. Now, what does that mean? That means domain and range is a thing, right? We spent the last lesson looking at domain and range for relations, and for that I kept it pretty simple. Once you start looking at graphs, it can become complicated pretty quickly, actually. So remember, what is domain supposed to be? Just a list of all your x values, right? What is range supposed to be? A list of all your y values. When you're looking at a graph, the only reason students tend to find difficulty with this is because they're still not comfortable looking at graphs in general. So that's the only thing that's really going to hold you back in this lesson is your ability to read and understand a graph. So what I'm going to do is I'm just going to go through some examples and show you how to find the domain and range for each one of these. Now, the first one, A. It's actually pretty straightforward because this graph is only comprised of 3 points, right? You have 3 coordinates or 3 ordered pairs. So when I go to list all of my x values, I can do that very easily. Look at your 3 points. -3, 1, and 4. You see that? 3 points. So I can look at the 3x values. So my domain will be -3, +1, and +4. There's my domain. Now my range, I'd do the same thing, but for the y values, right? -2, -1, +2. 3 y values, because all we have 3 points. So my range here, -2, -1, 2. Very, very simple. This is basically what I had you do last lesson, right? Just here's a list of some coordinates. Can you pick out the x values? Can you pick out the y values? That's not why I'm going over this lesson. That's not why I'm going through these examples. Because very, very few times are you going to have a graph where it's just points, right? Usually, a graph will have some kind of a line on it. So let's just kind of make sure we understand what we're looking at. When you see a graph with a smooth, continuous line, so you see the point -2, 2, and you see the point 3, 2. Those aren't the only 2 points on this graph, right? -2, 2 is like your starting point, and 3, 2 is your ending point, or end point, right? So your start and your end. But wouldn't the line have points all over it, right? I mean, isn't it basically saying every point in between these two, right? This graph represents every point in between -2, 2 and 3, 2. That means you can get points like this, right? You can have the point 2, 2, or the point -1, 2, and everything else in between, right? Every point in between these two is on the graph. Now, I can't list all of those numbers because it's like, think about domain. My x values. What's the x value of this point? -2. What's the x value of this point? negative 1. What's the x value here? Positive 2. What's the x value here? Positive 3. Those aren't the only x values, though, because you'd also get x values like 2.5 or 0.5 or negative 1.5 or any decimal in between, right? So it's literally, right, your x values for this graph would be every x value from negative 2 to positive 3, right? Now, I can't write that out. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Yeah, those are the whole numbers. What about 1.2? What about 1.3, 1.4, 1.5, 1.6, right? You can't write out all of the numbers. But listen to what I've said before. It's every x value between negative 2 and 3. Isn't there a way to use inequalities to show every number between 2 points? My domain for this graph, since it's supposed to be in between a negative 2 and a positive 3, right? Those are your x values. So x is between negative 2 and positive 3. And I just need inequality symbols, right? Less than or equal to, less than or equal to. How come it was less than or equal to? Because those are closed circles, right? Again, x is everything between negative 2 and 3. Look at the x value for the starting point. Look at the x value for the end point. Everything in between, right? What are you looking at here? Negative 2 is smaller than x, and x is smaller than 3. In other words, x is between negative 2 and 3. So sometimes your domain and range could be just a list of numbers. Sometimes you might have to use an inequality to show a whole list of numbers that you couldn't just write out on paper. Now this one's interesting with the range, because if you look at all 4 of the points that I've put on here, negative 2, 2, negative 1, 2, 2, 2, 3, 2. Every single point has the same y value. The y value never changes. So your range, which is supposed to be a list of all the y values, well, in this graph, the only y value you have is 2. The range is literally just 2. So x, right, as you go from left to right, the x changes. The x can be all these different numbers in between negative 2 and 3. But the y, since it does not go up or down, the y does not change. The range is just 2. Now, example C, we're complicating things a little bit more, right? Each one of these, we're just adding an extra layer on top of it. So we do the same type of thing, right? My domain is supposed to be the x values, right? So I'm looking at the x value here, negative 3, and the x value here, 2, right? Again, this graph would cover every x value between negative 3 and positive 2, right? It's everything in between there, right? So my domain will be everything in between negative 3 and positive 2. My x values go from negative 3 to positive 2. Here's the thing though. See how that negative 3 has a closed circle? I'll put a less than or equal to sign there. Do you see how this point is an open circle? I'll just put a less than sign there. What does this mean? Every point on this graph would have an x value between negative 3 and positive 2, right? You know, what's this point here? Maybe it's 0.5, comma 1. That x value is between negative 3 and 2. Maybe this point is negative 2, comma negative 1. Again, look at the x value. It's in between these two numbers. Open circle, you just don't use the or equal to part. It's the same thing with any inequality, and you've done that a lot. Closed circle, you put the line underneath. Open circle, you don't put the line underneath. So the x values go from negative 3 to positive 2. This time, since the graph does increase, it goes up, the y values are also going to have to be represented using an inequality, right? Your lowest point on the graph is negative 2. Your highest point on the graph has a y value of 3. What that means is that your range, or your list of all y values, is everything between negative 2 and positive 3. So my range, the y values this time, is everything between negative 2 and positive 3. Negative 2 is my lowest, positive 3 is my highest. With the negative 2 closed circle, it should be less than or equal to. With the positive 3 open circle, it should be less than. Finding the domain and range for a graph 100% depends on your ability to read a graph, to understand what it is you're looking at, right? And to understand the concept that when you look at a line, that line is made up of infinite points, right? Every single point in between these two. We're going to go over a few more examples here. The next examples I go over are going to make the graphs even more complicated. Okay. So, D. This time, your graph is broken up into two parts, right? This is something you're going to have to get used to seeing, right? So what you're looking at are basically two horizontal lines, right? You have this part of the graph, negative 5, negative 1 as the end point here, negative 1 comma negative 1 as the end point here. Then the second part goes from negative 1, 1 to 4, 1. So you might think that you have to have two different domains, and depending on the graph you might, but let's look at this. So this graph, this part of the graph, goes from negative 5 to negative 1, right? It ends at negative 1, right, for the x values, for the domain. The second part starts at negative 1 and ends at positive 4. So where this part ends the second part begins, right? So, since this one actually picks up where the previous one left off, we could say that the x values, or the domain, for this graph basically just goes from -5 to +4. It's everything in between -5 and +4. So my domain, -5 less than or equal to x less than or equal to 4. X is just everything in between -5 and +4. You're covering everything, right? Your range works a little bit differently, though. If you think about it, this is a horizontal line. Since it's a horizontal line, look at the y values. They don't change. -1, -1. Every point on this line would have a y value of -1. So one of my range values is -1. Now, the second part of the graph, +1 is your y value here. +1 is your y value here. The y value will never change for this part of the graph. It will always be +1. So my range is literally just the numbers -1, +1. That's my range. If you were to just sit and write out points that you see on this graph, every point would have one of those two y values. Every point up here would have a y value of 1. Every point down here would have a y value of -1. The x's would be any number in between -5 and 4. Final one here for these exercises. E. You're looking at a vertical line. It goes up forever. It goes down forever. I have the point 2, 0 here. Now, if you think about it, since it's a vertical line, it's not moving left or right. If I were to write any other point on here, the x value would have to be 2, right? If this is 2, 0, this could be 2, -1. This could be 2, 4. This could be 2, -3. No matter where I look on this graph, the x value is always 2, which means my domain, my list of all my x values, is just the number 2. That is the only domain value that I have. Now, for the range. This graph goes up forever and down forever. So if you think about the type of y values you could get, I have -1 here, I have -3 down here. Wouldn't that mean I could get like -7 down here? And go even further to get -98? What if I went up to 4 and then went up again to 5 and then up to 6 and then 7 and then 8 and then 9? You could get every number for y. 2, 4, 2, 7, 2, 11, 2, 98 million, right? The range could literally be any number. The y value could be anything. So how do I represent everything? Well, there's a certain symbol in math that kind of represents everything, and that symbol is infinity. right? The infinity symbol looks like this, kind of like a sideways 8, right? Well, since the y value could be anything, what I do is I say this. Y is in between negative infinity and positive infinity. Look at this. Y is between negative infinity and positive infinity. What is negative infinity? That just means you're going further and further into the negatives. Negative 1 million, negative 2 million, negative 8 billion, negative 9 trillion, right? Positive infinity is the same concept, but going to the positives. Positive 2,000, positive 2 million, positive 2 billion. Y is every number in between these two concepts, forever going towards the negatives and forever going towards the positives. Do you notice I didn't put equal to? Because how could you equal infinity? You can't, right? Infinity continues to increase and increase. Negative infinity continues to decrease. Therefore, this is how you represent everything, using inequalities. You'll learn other ways to do this in Algebra 2. For now, I want to focus on things that I've taught you, like using inequalities. Now, the last thing I would like to go over is a very basic exercise, and what we're going to do is determine if each value down here is in the domain of this graph. So I've given you a graph, and we will determine if these x values are actually in the domain, right? So look at the graph first. Make sure you understand the graph. Again, there's two parts to it, just like there was over here. This part goes from -2 to +1. So everything in between -2 and +1. This part goes from 2 to 6. So it represents everything between 2 and 6, right? So everything between -2 and 1, everything between 2 and 6. I'm ignoring the y values because right now I'm only talking about domain, which is x. So A, x equals 0. Let's see if that is in the domain of this graph. How do I determine that? Well, find x equals 0, which would be right here, and see if there's a point on the graph that would actually have that. You see how this point right here is on the graph? Wouldn't this point have an x value of 0? I don't know what the y value is. I don't really care what the y value is. But this point has an x value of 0, which means, yes, it's in the domain. So yes, x equals 0 is in the domain. Again, what does this part of the graph mean? Everything, right, x is everything between -2 and +1. Isn't 0 between -2 and +1? That means it would be in the domain for this part. Now the next number is -4. Well, if this point's -2, wouldn't that mean -4 is somewhere over here? And do you notice that there's no part of the graph over here? That means -4 is not in the domain. Again, think about what we said. This part of the graph goes from -2 to +1. Everything in between -2 and +1. The number -4 is not in between -2 and 1. Therefore, it's not in the domain. C says x equals 1. Now, x equals 1 would be right here. Up top, right, this part of the graph has nothing to do with 1 because this graph goes from 2 to 6, right? It starts at 2, but this graph ends at 1. So it seems like 1 is in the domain. But here's the thing. That's an open circle. Because that is an open circle, that means we can't actually use this one point. This is where the graph ends, but this one point here is not actually on the graph. So even though this point has an x value of +1, because it's an open circle, 1 is not in the domain. +1 is not in the domain. And then the last one, x equals 5. Well, if this x value is 2, and it goes up to 6, wouldn't that mean this point right here would have an x value of 5? And I do know the y value would be 1. Because, it's a horizontal line. Every y value has 1. I don't care about that, though. What I care about is the fact that this point here is 5, 1. Therefore, 5 is in the domain. So yes, 5 is in the domain. Again, wouldn't this part be everything from 2 to 6? And isn't the number 5 in between 2 and 6? So when you're asked this question, to determine if something is in the domain, you're basically trying to see if a point exists on the graph that would use that x value, right? I could ask you the same thing with the range, right? Like the number 1. Is the number 1 in the range? Well, there's a point that uses the number 1. So yes, the number 1 would be in the range. Would the number 5 be in the range? Well, these y values are all negative. This y value is a 1. I don't see any points that I could have using a y value of +5. So the number 5 would not be in the range for this graph. This is probably one of the more difficult things I've taught you, only because of the way we have to read the graphs. It's not really that difficult. You just have to familiarize yourself a little bit more with how to actually interpret these graphs. And with that, you now have everything that you're going to need for your assignments this week. Just in case you forgot from the last video or whatever, number of the day, 23. 2, 3.